Welcome, this is the 4.1 Ready Set Go homework solutions. Here we have graphing the following equation on the coordinate grid, determine if the point is solution to the equation. Here I'm going to show you plugging it into the equation first, then I'm going to graph it in decimals to show it how it is an equation, okay? Alright, number 1, y equals to 5x minus 2. Here are your points, 1, 3. So we know that the x equals to 1 and y equals to 3 based on that point. Okay, to check the solution, you plug it in. I substitute in the values for x and y. 3 is on the left-hand side. 3 is also on my right-hand side. Alright, let's see how it works in decimals. Here we're just going to graph it. Y equals to 5x minus 2. Okay, do you see how it's already graphed? Alright. Let's see if the point to 1, 3 works. So 1, 3. That is valid because it's on the line. Good? Let's do the next one. Y equals to negative 1/2 x plus 8. The points of 0, 7. X equals to 0. Y equals to 7. Substitute in. I say y is not equal to 2. Let's see if that is valid. So this is negative 1/2 x plus 8. Let's see if 0,7 was a valid solution. Nope, it was 0,8. 0,7's right here. It's off the line. That is why it's not a valid solution. 3. Y equals to negative x plus 4. The points are 2, 2. X equals to 2. Y equals to 2. Let's substitute that in. 3 is equal to 3. Seems like that is a valid point. Let's see if that makes sense when we graph it. Here we go. Let's see if the point 2, 2 works. 2, 2. Yep, that's right on the line. So, that is valid. Next, let's look at 4. Y equals to x plus 2. So, the point is x is equal to 1. Y equals to 3. That's based on that point. Plug that in, make that substitution. Let's see if 3, 3 is a valid point. Okay. 3. Oh, 1, 3. 1, 3. Yep. 1, 3 is a valid point. Next one. Okay. Just look at it when I'm making that substitution. Oops, sorry. Right. Let's see, y equals to negative 5 over 2 x minus 7. Alright. Okay. Let's see if negative 2 is a valid point. Nope, it's so far away from the line. Right? Not valid. Plug it in. Negative 2 is not equal to negative 4. Here's negative 6. You could look at the solutions there while I graph it for you. Let's see if the point 2, negative 5 is valid. 2, 5 is right here. Nope. Looks like 2 and 2 2/3 is a valid answer, but the 2, negative 5 is not valid. Right? That's why it's not valid here. Right? So those are just how you can check, okay? Here's your set. Determine if the two expressions listed are equivalent. Explain your reason. Here is the first one. Here's the second one. Here's parentheses. To compare it, you just want to make sure they're all in simplified expression. So, here we go. Distribute that negative 1. Simplify, you get 14 minus 3a minus 2. Those look exactly the same, so they are equivalent. Or you could just simplify this a little bit further. I think this becomes 12, right? If you subtract the 2 here, this becomes 12. Right? This would be a more complete answer, okay? Because this is simplified because there's no more like terms, okay? 8, 4b minus 10. The right-hand side has 2 parentheses 2b minus 5. Distribute the 2 to both sides. You get 4b. 4b minus 10. So we call those equivalent. 97. 7 minus 7 divided by 4. Here is x over 4 minus 7/4. Okay, so here, there's the really 1/4 out here because you see how there's actually a 1 here? Oops, sorry, there's actually a 1 up here. Okay, so 1/4 is going to be distributed to each term. So 1/4 times x becomes x over 4. 7 times 1/4 becomes 7 over 4. Looks identical, so you say those are equivalent. 10. Okay, 3/5 is your coefficient out in front. You want to distribute that to that w and then -9. Okay, becomes 3/5 w minus 3 times 9 is 27. 5 is on the bottom. The 3w, good. This is 27 over 5. They are not equivalent. Okay? Because, you see, this and this are not the same. Okay? These and this is not the same. That's why they're not equivalent. 11. Without solving, determine if the two equations below have the same solution. Here, I looked, I distribute, so I say the two equations are equivalent because the right-hand side just had to apply the distributive property and equals to the right-hand side. Okay. Next, 12. Again, we have 14 minus 2 minus 10. Right? So, 13. Okay. Here, this one is equivalent because you can simplify. So we would say they are equivalent for 12. 13. Okay. Distribute the 4 into each term. Gets you 4x minus 8 on top. 5's on the bottom. Multiply 5 to both sides. Simplify. 4x minus 8 equals to 100. Add 8 to both sides. That's what you get. Then divide both sides by 4. Gets you x equals to 27. Again, pause the video if you would like to see all the steps. I wrote the commentary here to explain each one of the steps, okay? So just pause it if you would like to see it in detail. Alright. Do I have 14 here? Nope, I have it on the next slide. Yep. 14. Here's the original equation. I want to get rid of that 4. I want to distribute that 4 to each term. Becomes 4x over 5 minus 8 equals to 20. Add 8 to both sides. That's what it looks like after you add the 8. Try to get rid of that divide by 5, so I multiply 5 to both sides. 4x equals to 140. Divide 4 to both sides. X equals to 37. Distribute, because I have to get rid of the parentheses first. Here I added because I'm trying to get rid of this. Then I deal with the fraction. Okay, so it's like that scenario. You have to work outside in, so the outside stuff, which is the minus 8, then you work in, which is the 5, then the 4. All right. 15. What's the most outward thing here? Is that divide by 5. So my first step is to multiply by 5 because that is the inverse of divide by 5, right? So multiply 5 to each side. 4x minus 2, right? Because the top is left alone. 5 over 5 is just becomes 1. 20 times 5 is 100. Add 2 to both sides because trying to get rid of that subtraction. Divide by 4. Divide by 4. X equals to 51 over 2. That's what 102 divided by 4 simplified to. Okay. Alright, and is that it? Yep, that's it. Let's go to the go part. Indicate whether the given solution values is a solution to the corresponding equation. Here you have a value a equals to -3. And you have 4a plus 3 equals to 9. That's the equation. So I substitute a in. A is equal to -3. That's the substitution right there. Simplify. -9 equals to -9. So we say yes, that is a valid solution. 17. We have x equals to 4/3. I substitute a is in, not a. I substitute x is in for 4/3. Simplify. 1/3. 1/2. That's not equal to 3 over 2. Okay. because ooh, wait, this is wrong. Sorry, because there's actually a 1 out here. Because this 3 over 3, 4 over 4 is 1. 1 plus 1 half does equal to 3 over 2. So we would say that this is, yes, this is a valid solution. Y equals to 2. Here, 2.5y minus 10 is equal to negative 0.5. Substitute in the y equals to 2. You get 5 here. You get 5 here. Minus 10 is negative 5. That does not equal to negative 0.5. We will say that's not a valid solution. 19. Z equals to negative 15. Okay, here's that equation. Very long. So here I dealt with this first. That's what I did. Right. So here's the equation. I distribute. Okay, look at how I'm distributing here. I can color code it to make your life a little bit easier. Okay, see how I am distributing it. Okay, then I am distributing this too. I can make that red. Okay, that's just what I'm doing. Oh, sorry, I distribute the negative 2. Yep. Negative 2. Okay, that's what I did. I distributed. You have to distribute both sides. Simplify, combining like terms. Alright, that's what I did. The 20 plus 2 is 22. Substitute z equals to 5 because that's what they asked. Alright, do some simplification. 10 plus 20 is 30. 22 plus 10 is 32. We would say that's not a valid solution. Alright, 20, same thing. W equals to 1/4. 4w equals to w plus 3/4. Here, plug it in. 4 times 1/4 is 1. 1/4 plus 3/4 is just 1. So we say that is a valid solution. 21, b equals to 5. Here's your equation. I did some distributing here to get rid of the parentheses. I simplified 6x minus 2 equals to 4x plus 8. Substitute here 5 plugged in, 5 plugged in. 30 minus 2 and 20 plus 8, 28. And 28 is a valid solution. Okay, there you go. I think, is that it? Yep, those are all your homework solutions for the 4.1 Ready, Set, Go.